Consider a lift which is accelerating upwards. What is the apparent weight of the passenger in the lift? In other words, if the passenger was standing on some bathroom scales on the floor of the lift, what weight would they read? In order to answer this question, we will draw a free body diagram of our passenger. So let's ask, what forces are acting on her? Well, there is the force of gravity acting downwards, which is equal to mg, and the other force acting on her is the upwards support force exerted by the floor of the lift. We will call this force P. Now, by Newton's third law, the force of the floor on the passenger must be equal and opposite to the force exerted by the passenger on the floor of the lift. This downwards force is her apparent weight. It is the weight that the bathroom scales on the floor of the lift would read. So let us write down the equation of motion for the passenger. We've got on the screen now the free body diagram. And so the equation of motion is P minus mg is equal to ma. That's because the resultant force on the passenger is P minus mg. Here I am taking the upwards direction to be positive, and substituting this into Newton's second law, F equals ma, where a is the acceleration of the passenger, which is obviously the same as the acceleration of the lift, we get that P minus mg equals ma. Therefore, P is equal to mg plus ma, which is equal to ma plus w, where w is the actual weight of the passenger. Let's put some numbers in now. Let's say the actual weight of our passenger is 490 newtons, and the lift is accelerating upwards at 2 meters per second squared. P then is equal to 490 over g times 2 plus 490, which is equal to 590 newtons. So her apparent weight is greater than her actual weight. If the lift was instead accelerating downwards at 2 meters per second squared, then P would be equal to 490 over g times minus 2 plus 490, which is equal to 390 newtons. In this case, her apparent weight is less than her actual weight. Notice that in this analysis I have taken the positive direction for the acceleration to be upwards. You should appreciate that positive acceleration means that the lift can be either moving upwards with increasing speed or moving downwards with decreasing speed. If the lift has negative acceleration, then it can either be moving downwards with increasing speed or moving upwards with decreasing speed. Okay, what would happen to our passenger's apparent weight if the lift cable snapped? The lift would be in free fall. In other words, it would be falling freely within the acceleration of minus g, the acceleration due to gravity. So let's substitute this acceleration into our passenger's equation of motion. And we get that P is equal to ma plus w, which is equal to w over g times minus g plus w, which, cancelling the g's, just gives us 0. So our passenger and the floor would not exert any forces on one another, and therefore the passenger's apparent weight would be 0. In other words, we have apparent weightlessness.